Welcome to Unit 4.2, Visual Patterns. Mathematics is the study of patterns. We look at patterns in numbers, and as mathematicians, we try to come up with formulas that help us make predictions. And so what we want to do in grade 9 is we want to be able to identify linear patterns. Now, obviously on a graph, a linear pattern would be something that would graph a straight line, because the word linear, L-I-N-E-A-R, has the word line in it. So linear means a straight line, as opposed to nonlinear, which would mean not a straight line. In the last lesson, you looked at some equations and you tried to determine which would be linear and which are nonlinear. And it turned out that those equations that had x's in them, that had no exponents, they weren't in the exponent, no square roots, and actually not in the denominator. So they had to be equations that looked something like this: y equals 3x, or y equals 3x plus 2, or anything where the x didn't have an exponent on it. And the y obviously didn't either, because it was y equals that. In today's lesson, we don't actually have an equation. We just have a pattern. We're looking at a diagram or a picture, and we're looking at the patterns, and we want to figure out, is this going to be a linear relationship or is it going to be a nonlinear relationship? So we're going to look at these first two examples in the handout, and then I'll leave you to look at the rest of them. So looking at this first one here, we're looking at how many logo pieces are there versus the step number. So in step number 1, I see 1, 2, 3 logo pieces. So this is the number of Legos, and there are 3 of them. And in step 2, I see 1, 2, 3, 4, 5 of them. And in step 3, I see 1, 2, 3, 4, 5, 6, 7 of them. And in step 4, I see 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. And if I follow the same pattern, 3, 5, 7, 9, I'm thinking that the next one's going to be 11. Now I'm not going to do the next one because there's a big jump from 5 to 10, so the pattern's going to be a little bit different. But we should be able to figure out what that number is. Okay, now, first differences. What this is what do you have to do to this number, so to 3, to get to 5? Well, we have to add 2. And how do you get from 5 to 7? You add 2. How do you get from 7 to 9? You add 2. And how do you get from 9 to 11? Well, you add 2 again. And so now what I'm going to do is I'm going to come down to the graph, and I'm going to graph. So 1, 2, 3, 4, 5. Okay, always the first column, that's always going to be your x's. That's going to be the horizontal axis. Okay, so this is our x, and actually it's not x in this case, it's step number. And then in the second column, so the second column here, that's the one that we looked at, and we just picked whatever step it was, and the number in the second column depended on what step we were looking at. So it's the dependent variable, the number of Legos, and let's call that L. And I think instead of calling this X, I don't like X sometimes. I like N in this case for number. So N for number. So step number, so this is my N axis. That's the independent axis. And then L, that's my dependent axis. And my L axis needs to go up to at least 11. So let's go 2, 4, 6. So this is 0, this is 0. Your scale has to be consistent, so if I'm going 2 jumps to get to 1, I got to go 2 jumps to get to 2, 2 jumps to get to 3, 2 jumps to get to 4. And my vertical axis is going up by ones as well, but I'm only marking every 2. So that's 8, this is 10, and this is 12, and I can stop there. So I don't have a step 0, but I have a step 1. So step 1 is at 3. Step 2 is at 5. Step 3 is at 7. Step 4 is at 9. And if I follow the same pattern, step 5 is at 11. And so we do get a straight line. Okay, so we notice that all of the first differences are equal. Now, how are we going to figure out step 10? You might have some ways of doing that. So to get from step 5 to step 10, that's a difference of 5, which means I'm going to have to add 2 5 more times. So I need to add 2 5 more times, which equals I need to add 10. So that's going to be 21. And to get from 10 to 27, well, that's a jump of 17. So to get from here to here, I'm going to have to add 2 17 more times. So that means I'm going to have to add 34. So that's going to bring us up to 55. And to get from 27 to 100, that's a jump. That's a big jump. That's a jump of 73. So I'm going to have to add 2 73 more times, and 2 times 73 is 146, and 55 plus 146 is 201. So that's one way of doing it. Another way of doing this is to come up with some kind of an equation. Now some of you may be able to figure out the equation. I know I'm going up by 2 every time, so here's how the pattern works for these. The number of Legos, so L. I have to take the step number and multiply it by 2 because those are the first differences. So I need to take the step number and multiply it by 2. So the step number, remember, is n. That's the step number. I need to multiply it by 2, but we don't usually write the multiplication sign. But for step number 1, if I do 2 times 1, that only gets me to 2, but I need to get to 3. So I have to add 1 to that. Let's just test it out for step number 2. 2 times 2 is 4, but I need to get to 5, so I have to add 1 to that. 2 times 3 is 6, but I need to get to 7. 2 times 3 is 6, plus 1 is 7. So whatever the first differences are, so this number here, that's the first differences. The first differences times the n plus 1 will get you to the equation. So let's take a look at the next example. We need to draw the next step. So I've got 1, there's the first one, there's 1, and then 2, 3, and then 1, 2, 3, 4, 5, 6. Okay, so I need 1. Okay, there's my 2, 3, 4, 5, 6, and now I need to add another. There we go. Okay, now this is asking for the number of toothpicks, not the number of triangles, so I'm going to erase those numbers there. All right. So, number of toothpicks. Step number 1, I count 1, 2, 3, 3 toothpicks. Step number 2, I count 1, 2, 3, 4, 5, 6, 7, 8, 9 toothpicks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 toothpicks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 toothpicks. All right, first differences here. I'm not sure what the next one's going to be. So here there was 1 triangle, 3 toothpicks. Here there was 1, 2, 3 triangles. 3 times 3 is 9 toothpicks. Here there's 1, 2, 3, 4, 5, 6 triangles. 6 times 3 is 18 toothpicks. Here there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles. 10 times 3 is 30 toothpicks. So I started out with 3. To get from 3 to 9, we have to add 6. To get from 9 to 18, we have to add 9. To get from 18 to 30, we have to add 12. I wonder what the next one is. It looks like these are going up by 3 themselves. So 6, then 9, then 12. It looks like this one might be 15. And 30 plus 15 is 45. Now when I go to draw this one, I still have 1, 2, 3, 4, 5. This is N. This is the step number. And then this is going to be, let's call it T for the number of toothpicks. And I got to get up to at least 45. So I'm going to go up by, I don't know, let's see. I'm going to go up by 2, 4, 6. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't think that's going to work. Let's go up by tens. 10, 20, 30, 40, 50. That's 0 and that's 0. Okay, so 1, I've got to put a dot around 3. So 3, this line here would be 5. So 3 is just below that. So there's that one. 2, I should be at 9, so I'm just under 10. That should be about right there. Okay, 3, I should be at 18, so that's just going to be under 20. 4 is going to be at 30. And then 5 is going to be at 45. Okay, I can see that this is definitely non-linear. Okay, this is notice the first differences are not equal. First differences are not equal. So that means that this one is non-linear, and I don't care if you do the rest of these on a non-linear relationship. This one over here is linear, and I want you to do the rest of these. I would also like you to figure out an equation for the linear ones. So let me just do one more here. Let's go to the next page. I'm going to skip this one because you can see here, step number 1, there are 3 trees, and then 5 trees, and then 7 trees, which is the same as the last equation that we did. The next one's going to be 9, and then 11, so that one's not very interesting right now. So let's go and let's do this next one. So we have snowflakes here. This one has 1, 2, 3, 4, 5. There's 6 snowflakes. 2, 4, 6, 7, 8, 9 snowflakes. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 snowflakes. So 6, 9, 12. Draw the next one. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Notice here there's one row of 3. Here there's 2 rows of 3. Here there's 3 rows of 3. So this one's going to have 4 or columns of 3. And then there's these extra 3 here. These extra 3. So 1, 2, 3. So that's 1, 2, 3, 4 rows of 3. That's 12, 13, 14, 15. So that one's going to be 15. So to get from 6 to 9, add 3. 9 to 12, add 3. 12 to 15, add 3. So if we add 3 more, that's going to take us up to 18. The first differences are equal. That means this is linear. This will graph a straight line for sure. The first differences are 3 this time. So to get from 5 to 10, that's going up by 5 on this side, which means we're going to have to add 3 5 more times, which is 15. So 18 and 15 is 33. And here that's going up by 17, so we're going to have to add 3 17 more times, which equals 51. Well, that takes us to 84. And here, to get from 27 to 100, that's going up by, what did we say before? That was 73. So we're going to have to add 3 73 more times. That's 219. Now I'm not sure what's 219 plus 84. 303. Okay, you don't have to graph, you only have to graph up to 5. So we're going to go 0, 1, 2, 3, 4, 5. This is n, that's the step number. And here, this is number of snowflakes. So let's call that capital S for snowflakes. It's got to get up to 18. So let's go 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So for step number 1, we're at 6. Step number 2, we're at 9. Step number 3, we're at 12. Step number 4, we're at 15. Step number 5, we are at 18. See, oops, that one right there. So there definitely is a straight line here. Okay, so now for the equation, so the number of snowflakes, that's S, equals, the first differences are equal to 3, so then we've got to go 3 times n, and then, but 3 times 1 is only 3. I need to get to 6, so we need to add 3 to that. You can test that with any one of them. 3 times 2 is 6, but we need to get to 9. So we add 3 more, that'll take us to 9. 3 times 3 is 9, but we need to get to 12. So we add 3 more to get us to 12. Okay, so your job is to complete the rest of these. If you find out that it's a non-linear relationship, then like this question here, you don't have to do 10, 27, or 100, and you don't have to find the equation. You only have to find the equation for the non-linear ones. Sorry, for the linear ones. You don't have to find the equation for the non-linear, just find the equation for the linear ones. And as usual, if you have any questions, let me know.